Hello students, so in this video we will be solving the remaining questions from the topic sets and relations. So the next question is the number of relations defined on the set A, B, C, D which are both reflexive and symmetric. So if you remember the formula, the question is very simple. Method 1 is through formula. Number of reflexive relations, if you remember, are 2 to the power n square minus n, where n is number of elements in the set, and number of reflexive and symmetric relations. Symmetric relations are 2 raised to the power n square minus n divided by 2. So with that the answer will be 2 raised to the power n is 4. So 4 square is 16 minus 4 divided by 2. So it will be 2 power 12 by 2 is 6. So 2 power 6 I think will be 64. So I recommend all of you to kindly remember the formula. The method 2 is, if you want to know the logic behind it, that will also, we can try explaining that also. So let us say there are A, B, C, D here. I'm constructing a matrix A, B, C, D. So of 4 by 4, right? That means this element is A, A, this element is B, B, and the third row, third column element is C, Z, and fourth row, fourth column element is 4, 4. So the total number of reflexive relations will be, that means all these diagonal elements should definitely be present. So that should be, that means for this there is only one way that it should be present. So like that 1 into 1 into 1 into 1. Now this element, right, this element can be present, need not be present, it can be present, it may not be present also. That means it has two possibilities. Like that, this will also have two possibilities. Like that, it will, like that, how many times should I multiply 2? So it should be 16. Out of this 16 I have to subtract 4, right? So it will be 2 power 12. So the number of reflexive relations are, these are number of reflexive relations, dear students. Reflexive relations are 2 power 12. Now number of reflexive and symmetric relations. Acha, now again reflexive as well as symmetric. That means this element, these elements should definitely be present. So it should be 1 raised to the power 4. Now if A, B is present, then B, A must be present, right? And if A, B is not present, then B, A should not be present. That means this element will have two options, and this will have only one option. That means depending on this will have only one option, right? If A, B is present, then B, A must be present, right? So there is no other option. That means what matters is these elements, right? These elements, there will be two possibilities. For these elements, there will be only one possibility depending on that. So it will be 2 to the power. How many elements will be present above the diagonal? It will be 2 raised to the power. Total number of elements are 16. Subtract the diagonal elements, that will be 12. So this will be the number of non-diagonal elements. Divided by 2, we get the number of elements above the diagonal. So this will be 2 raised to the power 16 minus 4 is 12. 12 by 2 is 6. That's how we got it as 2 raised to the power 6. That will be 64. So 64 should be the answer. Option 3 is